there. Okay, so other roots. We're going to take a look at cube roots and square roots, and then we'll look at a more complicated problem where we take a look at a ball, a sphere. So when you cube a number, like let's take 2 to the third power, that means write 2 down 3 times and then multiply them together. 2 times 2 is 4, times 2 is 8. Now, when you cube a negative number, so that would have to be in parentheses and then cubed, that means you write the parentheses 3 times and multiply. And here we get a negative times a negative is a positive. 2 times 2 is 4. Then we have to multiply that by -2. And a positive times a negative is a negative. And so I get a -8 there. So unlike squares, which kill negative signs, cubes keep them. So if the number started positive and you cube it, you get a positive answer. If a number started negative and you cube it, you get a negative answer. So for cube roots, if we have to solve something like what number to the third power is equal to -8, there is only one answer here. And that answer can either be written as the cube root. So it kind of looks like a square root, but it's got a little 3 in that hook out front. And then whatever number was on the other side goes there. Now in this case, there is an answer that's a whole number. The answer would be -2. So if we take a look at that homework problem, we've got 4x cubed equals 56. So 4x cubed equals 56. So like solving some of the other problems we did, to get rid of multiplication, you divide. So we would divide by 4 on each side. 4 divided by 4 is 1. 1 times x cubed is just x cubed. And then I have to take 4 into 56. So let's see, half of 56 is 28. Half of 4 is 2. 2 goes into 28 14 times. All right, and we could also check that on the calculator. So make sure I did my math right. Nothing wrong with whipping out a calculator here. What is 56 divided by 4? And my calculator says 14. So I did my cancellation right. The next thing we would do to get rid of the cube here is we take the cube root of each side. And so sometimes we would actually write it like this: cube root on that side, cube root on that side. The cube root and the cube cancel each other out, leaving just the x behind. But on the other side, we're stuck with that cube root of 14. Now, I don't have a lot of cubes memorized, so often I'll just go straight to my calculator and ask, what is the cube root of 14? And there we got to make sure we push the right buttons. So the Google calculator does not have a cube root button, so I'll come back to how to do it there. It's a little more complicated. Desmos does have an n root button. So let's go to a new line. So to use that, I select that I want to do an nth root, and it first says, okay, which root do you want? So I would put a 3 to say I want the third root, and then inside the box goes my 14. And every calculator works a little bit different, so if you're not sure how to use your calculator, ask. So this one says it's about 2.41-ish, and we're going to check that in a second. So this is about 2.41. And I'll show it on another calculator in a minute. To check, I go back to the original equation, plug it in, see what happens. So the original equation said 4 times whatever x is, I'm going to put parentheses there instead, is supposed to equal, question mark, 56. And to check, I just plug in what the calculator told me, that it's about 2.41. So I want to ask my calculator, what is 4 times 2.41 to the third power? And I'm hoping it's close to 56. And this is a good strategy for taking a test. So what is 4 times parentheses 2.41 close parentheses? Here I want the power button, which looks like an A to a B. Sometimes it's an X to a Y or a Y to an X, but whatever thing can give you a custom power, and I just put a 3 there. Hit enter, I get 55.99, which is pretty darn close to 56. So because I rounded this number here, I get a rounded result over there, almost 56. For other calculators that don't have a special nth root button, the following is what you have to do. Page. And the idea is that a root is a fractional exponent. So it depends on your calculator. So for example, I was just trying to do the cube root of 14, and my Google calculator, let's suppose that's the only one I had, didn't have this button. What I would do is take 14, and then I would raise it to the power 1/3. And on some calculators, that power has to go in parentheses. So it could be I need 14 raised to the power 1/3. Another way that power might be written is 14, that little hat key on the keyboard, to the power 1/3. So these are all the other ways, depending on your calculator, to find the cube root of 14. So make sure you can do that on your calculator. If you're stuck, let me know. So I'm going to try it here in Google. So 14 raised to the power, come on power, there we go. And then in Google, I have to put parentheses 1/3. And then I should get that 2.41 answer I got before. Anyone have a question about how to get a cube root on a calculator? Okay, take that as everyone knows how to do that. All right, so next kind of root that we have to deal with is a fourth root. And the thing about a fourth root is if you square a square, the rule is power to a power gets multiplied, you get the fourth power there. And so it turns out a fourth power is like a square, because it's a square of a square. So for example, if you had x to the fourth power was equal to 81, because it's like a square, there's two possible answers here. There's the positive version, so just the fourth root of 81, or the negative version, which is just the opposite of the fourth root of 81. And we could ask what that is on a calculator. So calculator, clear. So 81 is my base, and then I want to raise that to the power, parentheses, 1/4 would be the fourth root. And Google says the answer on a good day is 3. Check with Desmos, 81. Here they have, oops, I did it in the wrong order on Desmos. Start with the nth power. You want the fourth root, and then the 81 goes inside. So every calculator is a little bit different. Desmos says 3. So if there's a root button, use it. If there's not, then you have to use the fractional exponent version. Okay, so that's fourth roots. Next, this problem is a wee bit more complicated. I'm going to copy this. Let's see, I can't easily copy it. I just have to remember it. Let's see, we have a rectangular slab. Let's read it from the beginning. An artist is creating a sculpture using a sphere made of clay to represent the Earth. The volume of a sphere is given by this equation right there, where the radius, where r is the radius of the sphere. The artist has a rectangular slab of clay that is 4 inches wide, 6 inches long, and 2 inches high. So I'm going to try to draw that in a sec. We want to know what's the radius of the largest sphere the artist can create with this clay. All right, so we have 4 by 6 by 2. And it's a rectangle. So we have this box of clay. And we want to turn the box of clay into a sphere. And as far as the volume of a box of clay, it's just width times length times height. And they gave me that. They gave me that. Let's see, what was it? The width is 4, the length is 6, the height is 2. So 4, and was that centimeters? Inches. Okay. So we have 4 inches times 6 inches times 2 inches. 4 times 6 is 24. If we double 24, we get 48. And inch times inch is cubic inches or inches cubed. So I'm going to write inches cubed. And sometimes we might state that as 48 cubic inches. Just to get a picture of what I'm doing, I have a width of, let's say that's 4 inches. And then it has a length of 6. And then the height up from that is 2. So maybe 2 is probably about that high right there. So if I go straight up, so here's my block of clay to the best of my artistic ability today. So there's my 2 inches there. And again, I want to mold that into a ball, a sphere. So here's my best sphere today. And we want to know what is the radius of this ball if we take this block of clay and turn it into a ball. So in order for that to happen, we need to know that equation for the volume of a sphere. And the problem said it's 4/3 times pi times the radius to the 3rd power. So all we have to do is just set that equation equal to the amount of clay that we have here. So we can squeeze that in here. So I've got 4/3 pi r cubed equals 48. And we solved the equation kind of sort of like this a while back. To solve this, I have to get rid of the 4/3 and I have to get rid of the pi. And there's a ton of ways to do it. So I'm going to deal with the fraction first. One way to get rid of a fraction that's multiplied is to multiply by its reciprocal, which means just flip it. Because if you do that, you get 3 divided by 3 here, and you get 4 divided by 4. And so they cancel out there. And I have to do the same on the other side. So I have to multiply by 3/4 on that side. So again, the whole point of this is 3 goes into 3 once, essentially canceling, 4 goes into 4 once, and multiplying by 1 is kind of dull. So I get just the pi left there and the r cubed. And the other side, I got to take 4 into 48 and then multiply by 3. So we could ask our calculator. Dividing by 4 usually works out pretty nice. What is 48 times, what was it again? 3/4. 3/4. My calculator says it's 36. Anyone else get that? Someone help me out here. Am I correct on the 36? Let's see, we got a chat. Chat is yes. Thank you, Jesus. Forgot to turn the chat back on. All right. So that worked out nice. If it was a messy decimal, I might write it a little bit different, but 36 is nice. Then we got to get rid of the pi. Now the pi is just a single number multiplied here. And so to get rid of a multiplication, we divide by it. Now multiplying by pi is kind of messy, so I think I might leave it like that. Otherwise I have to worry about rounding multiple times, which the computer might get upset with me on. So here we've got pi divided by pi is 1. 1 times r cubed is r cubed. And I have that 36 over pi on the other side. The last step here is to just transfer that cube to a cube root on the other side. So then r is going to be the cube root of that whole fraction. And so I have to make sure the 36 and the pi end up inside my root. So next challenge is trying to type that into a calculator right there. So I'm going to do it on 2 different calculators. Let's see if we can agree on the answer. Once you get an answer for that R, plug it into the chat to see if the rest of us are okay with it. All right, so Google, I want the square root 36 over pi. And again, it's super important that you know how to master your calculator. So please do this. All right, so we got one answer. I got 3.38. Okay, so Zach and I disagree on that. So I'm going to go to a different calculator to make sure I didn't screw it up. Let's see, and I make mistakes like this every day, so I always double check. Do I have my numbers right? 36 over pi, yep. Oh, did I do a cube root back there? I didn't, I did the square root. Okay, so I think Zach's right, I'm wrong. Yep, I used the square root by mistake. I forgot my Google calculator does not have a cube root button. All right, so let me do that again. Yep, Zach and Larissa. Oh, Zach and Larissa differ on 1 decimal. All right, let's check that out. Pi close, raise that to the power 1/3. And Google says 2.2545. So I would agree with Larissa's answers. It would be 2.255. Let me check in Desmos, which does have a cube root button. Root cube of 36 over pi. And then the question is, does it look like the pi is in the root? Yeah, it looks like it is. 2.25, and I would round that to a 5. Yep, agree with Larissa there. So it's about 2.255 to the nearest thousandth. And that would be in inches. So if I go back to my picture, let's see. So I was thinking in my picture, where's my pen? No pen, oh, there you are. So I was thinking this was about 2. Yeah, it looks about the same length right there. Yeah, so if this is the block of clay, the ball would look about as big as I drew it here. Not the best artist in the world, but not too bad. So I think the radius is about 2.255 inches. So just over 2¼ inches for the radius. Nice work, you guys. Okay, let's stop that recording there. See if there's any